All right. A very good morning to all of you. I know we are privileged to be your first or probably second session at the start of reInvent. Hope you all had a very nice and safe flight to Las Vegas. My name is Siddhartha Roy. I'm the general manager for the AWS Snow Family of services that spans edge compute, edge storage, and data migration. And speaking alongside me today is going to be Jason Esputis from Axiom Space and Matchett Kranz from Kone Corporation. They have some very good talks lined up as well. So in terms of agenda, let me give you a quick rundown. I'll talk a little bit about the continuum of the AWS services from the cloud to the edge, and really talk about the motivations of how customers are asking us to extend the cloud, the reasons behind the extension, the why and the how. And then I'll double-click on some of the services in the continuum and give a little overview of each of the services, Local Zones, Outposts, Snow, and IoT. And then give some of the use cases. And then following me will be our guest speakers. Jason will speak to how they are extending the cloud at Axiom to the low Earth orbit in space. And he has some good use cases lined up. He's going to talk a little bit about the vision for Axiom and how that's interleaved with edge computing. Similarly, following Jason will be Message, talking about how Kone is co-innovating urban journeys with AWS. Essentially, how they're extending the cloud to the edge in terms of innovating in mobile pathways for global customers all over the world. And then at the end, we will follow up with a little bit of a Q&A. Please feel free to queue up or ask your questions. And if you cannot entertain your questions on stage, we'll be at the back or at the outside to take your questions as well. All right. So let me start with learnings from customers. At AWS, everything we do starts with the customer. Right? We basically go and work back with customers. And what our customers are telling us are three things. One, they'd like to extend the cloud. And the motivations behind that is they want to run applications at the edge. And I'm going to talk about the motivations of why they want to do that. And to be able to run applications at the edge, they need to extend the cloud infrastructure and services that are consumed by the edge applications. Okay? So that's number one. Second, what are the use cases in terms of the motivation for running those apps at the edge? There are three use case motivations. One, low latency. Some of these applications need to run at the edge simply because they cannot tolerate variations in latency. They need very low latency for quick response times, number one. Second, they need to do edge local processing. They're generating lots of data. They need to do the processing of the data right there where it's created, number two. And third, for data residency reasons, they'd like to keep the data on premises or in a colo in a certain fenced or geo-boundary because of EU regulations or other government entity regulations. So that's the number two, the motivations for the use case. The third, we keep hearing customers at the edge and on premises, they have a wide variety of solutions. And they're not able to enlighten those with the cloud. Typically, the tooling is different. The infrastructure is different. The integration with AWS is not there. So in other words, they are expensive from sometimes a CapEx perspective, and also operationally, they're difficult to maintain because they're very different. So that was the third motivation. Now, let's double-click a little bit deeper on the motivation for why folks need to run applications at the edge. So latency sensitivity. As I said, one of the first motivations is there are equipment and processes. If you think about IoT, they are driving equipment and certain human processes or healthcare processes that need quick response, right? They need low latency or variables, very low variables in latency. That's the need. Secondly, interactive workloads. Think about design, simulation, visual editing, augmented reality, virtual reality. They need very quick responses as well. And sometimes multiple varied workloads and infrastructure on premises need to interact with each other. that necessitates the need for a very low latency as well. The second motivation is local data processing. Customers are creating large amounts of data within their data centers, within premises, or even outside of their data centers or premises at the rugged mobile edge. And much of this data, structured, unstructured, needs to be processed right there. I mean, sending the data over to the cloud, processing it there, and sending it back is just too long. And customers need that edge local processing because they want to make edge local decisions. Typically, they want to kind of curate the data, act on the data. Example is a video processing. They might need to do something on the video processing streams right there to curate the data right at the edge before they send it over to the cloud. And third is the residency reasons. Customers are increasingly telling us they need to keep their data in their colo or in their data centers in their control, within their processes and regulations. Because our customers are hearing from their customers and public sector entities that they need to do that. So we are very, very mindful of these three drivers of use cases. And when we designed and we were extending the cloud, each of our services addresses one or more of these. I'll talk a little bit to those. So in addition to extending the cloud, customers want consistency and symmetry. They have invested in the cloud. Many of our customers obviously have moved to the cloud. That's the best place to start, right? When you look at the cloud and when you want to extend that, they want to, first of all, have the same reliable infrastructure on premises, at the edge. So think about Outpost. It's the same. I'll talk a little bit to that. It's the same hardware that is extending onto the edge, right? Think about the ownership model has to be very similar. It is like a service. The edge services are very similar to cloud. You don't pay for the hardware. You basically buy the service for as long as you need it. Third is they want the same APIs for consistency. Think about a cloud-born developer writing an API and something at the cloud. They need the same API and consistency at the edge. Why? Because they want to do a write once and run anywhere in the cloud. Finally, the same tooling. They want the same tooling as the cloud. They want the same operator experience, the same edge developer experience as the cloud. And finally, the same pace of innovation as the cloud. Customers don't want to have a new way of finding things in the cloud, okay? So let's talk about how customers are extending the cloud to the edge, right? First, we have our global AWS infrastructure. These are all the regions that we love where everything runs in the cloud. If you're extending that, the first click stop in the extension is local zones. If you think about local zones, why is local zones important? Local zones is about bringing your edge applications to metro centers. Think about metro centers as big metros like Delhi, Taipei, Los Angeles, Chicago, where many of our customers reside, and they're running their applications there. So local zones is about bringing those applications over to metros closer to the edge customers. That's number one. Second, we have gone a step further. We're integrating our APIs and services and bringing them to 5G networks. So if you're on a 5G network with a CSP and you want to kind of run AWS, we are bringing AWS services and infrastructure at the 5G location with Wavelength, number two. Third click stop is think about on-premises. Because of data residency reasons, some of our customers will want to keep their data with them in their colos and on-premises. That's where Outpost comes in, right? Outpost offers racks, multiple racks, or one rack and multiple servers. And that's where customers can run AWS connected to region, many of the services that are offered in the cloud with the same tooling. And then one more click stop is the far edge, where the Snow Family plays. This is often what we call the rugged mobile edge, which has denied, disrupted, intermittent, and limited connectivity. So think of these as locations that are unconditioned, where there is no data center, there is no rack form factors. It might be a drone, construction site, on a ship, on many other locations that we will talk about later in the session. And then finally, with AWS IoT, we are bringing a lot of these AWS closer to endpoints where we have the sensors, right? You have a lot of sensors, whether that be a smart factory or a city or a healthcare system or automotive connected cars. We are bringing AWS IoT and AWS close to those sensors. So let me transition a little bit now and talk to a few of these services and give you a little bit of an overview and talk to some of the use cases that these services are helping solve. Okay? Before I do that, let's talk about the cloud first. AWS has been investing in infrastructure for the last 14 years. We are continually expanding and adding more regions, right? We recently announced the Hyderabad region and also Switzerland and Spain, most recently. So all our regions have multiple availability zones, right? They have 3 or more AZs, as we call it, for high availability within a region, right? So a lot of our customers are running their applications today there. Now, we are not stopping there. We want to bring AWS outside of those regions, as I said, to local zones. We have 34 new local zones that we have announced, right? And we will be announcing many more, right? The key use case here is to bring applications close to metro and industry centers, right? So let me talk a little bit about the services running on local zones. So what are these services? So if you look at these services, we run traditional EC2 instances, right? Think about your favorite storage or compute-optimized instances that are running close to these locations, right? Think about accelerated instances as well. They are running close here, right? Now, if you think about containerized workloads, besides EC2, you can run EKS and ECS as well. And we offer AWS Direct Connect, which can be used to tunnel back to region, right? And you can offer a lot of low-latency access on the AWS network, not on the public network. So all in all, we have a rich set of services with AWS local zones. One more example is the VPC, where you can overlay your virtual private cloud and really create a traditional network that your applications know and use, right? And you can overlay that on top of your physical AWS network and your network. So let's talk about a use case and good example here. So one of the examples here is Netflix, a brand that we all use, or most of us use in our daily lives. So when you're seeing the next movie or video, think about the artist that created the video, what they need to do. They need to work on very precise, render a lot of precision images. They need to manipulate a lot of data, right? They're constantly doing that at very high-end workstations, typically in Netflix's headquarters, right? And because they need very low latency. The customer experience, in this case, the artist experience, the digital experience has to be very, very super cool. It needs to be done very quickly, under 5 milliseconds. So Netflix had this challenge, especially when the pandemic hit. They were wondering, how should we handle and deliver the same experience to our creators and artists when they are sitting in their home, sitting remote in their home? So the solution here was to tunnel basically the animation hub that Netflix runs to local zones over Direct Connect. And Direct Connect made the latency still under 2 milliseconds, right? Where customers, in this case, the artists and creators, could access this from their homes and still have a good artist experience, right? So at the end of the day, Netflix was able to still retain the mobility and the remote lifestyle of their artists while still giving them a smooth artist experience. A very good story here. All right. Now let's switch gears. I talked about local zones. Let's switch gears a bit and talk to Outposts. Outposts is about bringing AWS on-premises with a complete solution. System, software, hardware, firmware, management tooling, everything. So if you think about Outpost, it's the same AWS designed infrastructure. Okay, think about the same AWS designed infrastructure that you have running in the cloud, and it's based on the AWS Nitro system that is also used in the cloud. We are bringing the same infrastructure on premises in racks or 1U, 2U servers. Second, these systems are fully managed and operated by AWS. Okay, so in addition to the CapEx, the operational expenses for on-premises is much, much lowered, right? And then finally, you're getting a single pane of glass with the same APIs and toolings as in the AWS regions, right? So if you think about this, it is the same cloud services and APIs that are brought on premises to your colo and data centers. Okay, so let's talk a little bit about the Outpost family. Outpost comes in two flavors. One is the Outpost racks that can be deployed in a single rack or multiple racks, right? If you have a lot of compute and storage needs, you can do that with Outpost. So you can bring them on, and you can do this with Outpost, and you can run large compute, storage, networking with all the AWS services locally. Now, for environments that are space-constrained, don't have physical capacity, we are bringing Outpost 1U, 2U servers, the 1U, 2U rack form factor servers in your colo. You might be having an existing colo with your own racks. We're going to, Outpost 1U, 2U is going to fulfill that need. Same philosophy of bringing AWS services and APIs, but in a much smaller form factor. Okay, so let's talk a little bit to the services that can run on Outposts, right? Similar to local zones, let me start again with compute. Outpost offers Amazon EC2, the EC2 that you use and love in the cloud. And it offers containerized workload support with Amazon ECS and EKS as well, right? It offers you highly available databases with RDS and Elasticache. And it also offers you application load balancers as well. And in terms of storage, it offers you block storage with Amazon EBS, along with EBS with local snapshot support. Also offers S3, the same S3 that you have in the cloud on premises on your Amazon with S3 storage as well. So it offers you a rich set of services on compute, storage, networking, and then layered services on top. Let me double-click a couple of them. So EKS, because AWS Outpost is tethered to region, EKS support the concepts of local clusters. What that means is if your Kubernetes clusters, if there's a disruption in service and connectivity back into the cloud, the EKS clusters can run locally, right, without a reliance on region, right? They can do so for a finite amount of time. So Outpost is meant to tolerate latencies and glitches in the network, although it needs a network connection back to region. Second, you see RDS there. RDS you have local AZ support. So if you need highly available RDS, Amazon RDS, you can do that with Outpost, right, by having a 3AZ setup there with Outpost. Now, let me talk about an example and how a customer is using Outpost and lighting up some of these services and also using the cloud in combination and delivering an experience for their customers. So let's talk about Philips Healthcare, right? Philips delivers preventative healthcare for their patients, right? So that healthcare, preventative healthcare, highly relies on predictive analytics and AI/ML. The challenge here was in Philips's on-premises facilities, they had disparate storage systems and disparate compute network and storage. They didn't all come together very well. The API tooling was different. The infrastructure was different. It was very expensive to maintain. It didn't run AI/ML on it. So a lot of issues. So Philips partnered with the AWS Outposts team and figured out the solution and really figured out, they did multiple things. One is by bringing Outpost, it harmonized the infrastructure to one set of hardware, right? Number one. Second, in terms of tooling and operational expenses, it was managed by AWS. So there was a lot of cost savings there. API and tooling, same as in the cloud, okay? When they brought these services in, because Outpost is connected to region, combined with EC2 on Outpost, they could use some of the AI/ML capabilities in the cloud. And with the totality of EC2, AI/ML, the lower cost infrastructure, the lower operational costs, they were able to deliver value to their customers, right? To their patients by delivering more predictive analytics and thereby more preventive healthcare use cases and scenarios. That was a very nice outcome from Philips. All right. Let's switch gears a bit now and talk about the rugged mobile edge. And let me introduce Snow. So first of all, what is the rugged mobile edge, right? We think of the rugged mobile edge as unconditioned locations where there is dust, where there is no conditioned power, it doesn't have cooling, right? It might be extremely hot, extremely cold, but a lot of data is being generated in those sites. Think about ships, aircrafts, trucks, drones in multiple locations, mines, many other rugged locations, right? And these rugged locations may or may not be connected to the internet, right? We assume that they are not, right? So Snow is all about operating in what we call, this is an industry Department of Defense term, DDIL environments, denied, disrupted, intermittent, limited. Snow services don't rely on the cloud. They can operate independently of the cloud for months and years, right? It doesn't have any reliance. The control plane and data plane is all local on the devices itself, right? Now, Snow Cone comes in two flavors. One is the Snow Cone device. Snow comes in two flavors, the Snow Cone device platforms and the Snowball Edge device platform. So let me talk a little bit about Snow Cone first. We announced Snow Cone back in July of 2020. The initial announcement flavor was the hard drive version, right? That has around 8 terabytes of capacity. So think about Snow Cone as a tissue box-sized device, around 4.4 pounds. It's highly effective. It has compute, storage, network, and AWS services all integrated. Highly effective for mobile workloads in a soldier's backpack, or in a car, in the back of a car, or on a drone, where it is maybe static or maybe moving, and really capturing a lot of data, processing a lot of data, and then maybe optionally moving the data to AWS, online or offline. I'll talk a little bit to that. So think about Snow Cone. These devices can go anywhere. It has two usable vCPUs, small amount of compute. It can, as I said, capture the data, process the data, do edge local AI/ML on the data. And then if you want to keep the device there, you can do that for another use case, or transfer the data online with integration with data sync, or you can ship the device back to AWS to region where the data gets ingested, right? So pretty cool use case. Now with Snowball Edge, we have two flavors of the Snowball Edge. One is the storage optimized flavor. We have 80 terabytes of usable capacity today, right? And if you need a lot of storage, you can deploy the storage-optimized Snowball Edge. And then we have the compute-optimized Snowball Edge. If you need a lot of compute, you can deploy the Snowball Edge compute-optimized. Many of our customers deploy these individually. They might just deploy the Snowball Edge itself, storage-optimized, or a Snowball Edge compute-optimized, which has a lot of compute, a little bit of storage. Many of our customers, those are traditionally hyperconverged deployments. But many of our customers deploy them in layers. They might need a compute layer because they need a lot of compute capacity they're capturing a lot of data, and then they're processing a lot of data, and then they need to store it. So they have a separate compute layer and a separate storage layer, right? And the beauty is that in the storage layer, we offer S3 storage clustering. So you can take a bunch of these devices through the shared nothing architecture. We offer a scalable, available, resilient pool of S3 storage, right? So if one of the nodes goes down, the system keeps operating. So this is available for clustering and scale and connectivity. That's your Snowball Edge example there. Now, we recently refreshed the Snowball Edge compute. What did we do? We bumped up the CPU from 52 vCPUs to 104 vCPUs. We bumped up the storage. We bumped up the storage from HDD to SSD. We reduced the storage from 52 to 28 terabytes, but we offered all NVMe SSD storage. And we doubled the memory to 468 gigabytes. Now, why did we do this, right? So many of our customers needed to run denser AI ML workloads. They want to run a lot of compute at the edge. They are doing a lot of inferencing and training. 52 vCPUs was not enough. So they needed 104. So that's why we gave a lot of compute capability. And along with compute, the memory as well. And many of these Snowball Edge devices are being deployed in rugged environments. Think trucks in the back of a Humvee, think aircrafts, think ships. And going all SSD makes it very conducive to mobile environments where there is no spinning media involved. That was the motivation for going all SSD. Now, another use case where this is super useful, and you will see this example in the AWS Village if you swing by, is private 5G in a box. So if you think about private 5G, the Snowball Edge devices are often the command and control for a private 5G network. And before this device was offered with the refresh, you would need to run your 5G core on one Snowball Edge and your RAN stack, which is the radio access network, on a different Snowball Edge, or maybe on a different device as well. And then you have your antennas and other things. With this refreshed 104 vCPU Snowball Edge device, you're able to run everything together in a box, what we call private 5G in a box, your 5G core, your RAN stack as well, and your mobile edge computing MEC application, 3 things altogether. So that's your Snowball Edge compute-optimized refresh use cases a little bit. And let me talk a little bit quickly about the Snow family of services. Similar to Local Zones and Outposts, we offer EC2 compute, traditional compute with EC2. We offer containers as well with EKS Anywhere. We are announcing soon EKS Anywhere on Snow, which gives you orchestration of containers. We're setting up a Kubernetes cluster, deploying the cluster, managing the cluster, doing constraint load placement, anything you do with traditional Kubernetes as well. In addition to VMs and containers, we are also supporting Lambda, which gives you serverless compute as well, right? Storage, we support S3 storage and Amazon EBS as well. Now, on these foundational services, we support the Greengrass platform as well, which lets you run a lot of these IoT services on Snow as a first-party offering device, right? Now, what does this all mean, right? These services, again, as I said, they can operate denied, disconnected, intermittent, limited, right? These services, when we bring them to Snow, they are operating locally with no connectivity to the cloud. Now, if it finds connectivity to the cloud, great, it can do so, right? One example is data sync. So remember I was telling you how in the capture phase and the process phase, customers may need to move the data. So we have data sync built into the device. If you need to access the internet and do data sync to the cloud, you can do that, right? Or you can do data sync to another device as well. So again, the genesis of Snow is to operate completely disconnected, but it can light up with more services if it finds connectivity to the internet. So let's talk about a use case for Snow. One of the use cases for Snow is about the IoT services, the 5G services. So one of our partners, Mavenir, teamed up with their partners, Spark and Curious, to build a solution for their end customer around safety and hazard detection. Here the problem is, how do you make sure your operators are safe? So Mavenir provided the 5G core, which allows you to set up a 5G network with different video censoring streams and run the 5G on the Snowball Edge. And Curious provide the video analytics and the computer recognition, computer vision software of it. Together, Spark put this together with Mavenir and Curious to really deliver a solution which did real-time detection of hazards. For example, a construction specialist going near a hazard like an excavator, or any office employee kind of going too close, and it would give real-time warnings and detection. And I believe we have some demos also. You will see very similar demos in our AWS Village in the hybrid cloud section as well. So, and then rounding out the final service, let's talk about IoT. IoT has permeated our lives. AWS IoT specifically has reached many industries across the board, where we are offering IoT to improve the performance and productivity of industrial processes. We are using IoT to remotely monitor and have the well-being of patients. It's increasing the productivity in agriculture crops. It's managing a lot of sustainable energy. It's a predominant endpoint in a sensory situation like monitoring a connected car for vehicle and mobility behaviors. So when you think about IoT, IoT offers a wide variety of building blocks and capabilities, right? IoT offers, for customers who want to put their own solution together, IoT offers a rich breadth and depth of services that can be put together on a third-party hardware running FreeRTOS, the common IoT core OS. And on the other hand, if you want a very purpose-built solution, IoT is also offering purpose-built solutions. For example, IoT Fleetwise, right, is a purpose-built solution. And then if you need a very custom-built solution, you can do so with ProServe, and IoT services teams has a lot of consulting partners who can put the solution for you. So let me end this section a little bit with one example with LG Automotive. So if you think about LG Automotive main business is to provide solutions for auto car manufacturers. One of the challenges LG had was they needed to ingest data from the edge, from cars, agnostic of any car model, very quickly. And they needed to ingest the data from CAN sources in the car, for different types of sources in the car. And they needed to put that data in a big data platform and then use AWS Data Pipeline to draw insights on that data for rich behaviors, right? Rich insights on the data. So LG partnered with IoT Sitewise, basically, and figured out a way to deliver the vehicle data platform and also the high-speed ingestion. And they offered this as a service to their end customers, resulting in a lot high mobility insights, vehicle behavior insights with both simulated data and real-time data that was collected. So a good outcome here. So with that, let me transition a little bit over to my guest speaker. Please welcome Jason Esputis from Axiom on stage.
Thank you, Sid. Good morning, everyone. Good with sound? Yeah. So, talking about cloud in space. And before I dive in, I wanted to give you the punchline for this talk. The punchline is the past 25, 30 years since the internet was invented, we've culminated in what Sid just talked about, wonderfully about the advancement in compute services and cloud services at a global scale. And we have heterogeneous communication between my phone in my pocket to potential data storage in Hyderabad, right, for particular use cases. In the next 25 to 30 years, all that infrastructure and capability is going to be replicated, migrated, and proliferated in space. And that's a huge opportunity in the next 30 years. It's a really exciting time to be alive, let me tell you. So that said, I want to give you a quick intro to Axiom and what we're doing, and then slowly bring you to the aspects of how we're collaborating with AWS and on-orbit cloud capabilities. So our vision is a thriving home in space for everyone, anywhere. And our mission is to create a space station in space that improves life on Earth and extends economic opportunities in space for everyone, everywhere. And that's our mission. And we are well underway in our mission. So by the end of 2025, we will have our first module up on the ISS. So that'll be history. So it'll be humankind's first commercial space station module attached to the ISS. So whereas the previous infrastructure was government-owned, government-operated, government-developed, the future of space stations will be privately owned, privately operated, and constructed. We have modules thereafter for the next few years until the end of the decade, with anticipated detachment from the ISS by the end of this decade when the ISS starts to retire. And why are we doing this? We're living at a juncture of economic renaissance in space. So just the past few years, we've had dozens of private citizens go to space, either low Earth orbit or the upper edges of our atmosphere at the boundary of space. And that's going to continue, it's going to grow. And Axiom just did its first private astronaut mission with 4 private citizens going to the ISS just this April. And this path is laying the foundations for not just having people visit space for short duration of time, but the foundations for having people live and work in space in the dozens, hundreds, and someday, I think in our lifetime, in the thousands. And all these use cases you see up there is the reason why. There's a tremendous amount of economic opportunity that is synergistic with population growth in space. So let's talk about advanced pharmaceuticals. The ISS has proven in the past 20 years that the lack of gravity in space actually is very beneficial to making new drugs, new biotechnology. The physics is different, so you can make things that are potentially far more advanced and better than you could on the ground. The same with advanced materials. There's applications in making bigger structures, better satellites, better spacecraft in space because of no gravity. There's applications in cloud services that I'll be talking about as well. So the point here is that this entire spectrum of economic opportunity that will go hand in hand with hundreds of people living and working in space is all underpinned by common technological need, and that need is data infrastructure. And that's why we're partnered and privileged to partnering with AWS on starting to lay the foundation for what proliferated space-based data infrastructure looks like. And so in April, as part of Axiom 1 mission to the ISS, we deployed a snow cone on the ISS. As Sid mentioned, snow cone is a very resilient, compact device that can accomplish a variety of workloads. We actually put it to test. We ran some machine learning algorithms to filter images taken on the ISS and help reduce the latency and the workload on the ground for having to go through the filtering of those images. And it worked. Today, and actually as part of the Axiom mission, we are demonstrating additional use cases that will leverage snow capabilities and edge capabilities in space. On the left is a bioexperiment where our astronauts looked at cells undergoing simulated cancerous growth to see how the lack of gravity could affect that growth, either slowing it down or changing it, so it can give us insights in discovering new ways to attack cancer that we otherwise couldn't do because of gravity on the ground. And on the right, we have our astronauts from Canada, Mark Pathy, that's demonstrating the world's first holoportation demonstration between space and the ground. And so if you think about astronauts going to Mars, 6-month one-way trip, if one of them gets sick, you can't depend on Earth to have them come back to normal. So these kinds of demonstrations, entangled with on-orbit edge capabilities, are key to maintaining human life as we expand in the solar system. I love this quote. It's by Lisa Costa, Chief Technology and Innovation Officer for the Space Force, the US Space Force. She talks about the need to grow the infrastructure in space to support what I just talked about, the replication and proliferation of terrestrial-grade networking, data transport, data storage, data compute, and cloud service in space. Because as we grow our footprint, as we grow the needs, as we grow our propensity for space exploration, as we talk about growing economic opportunity, all that will require more and more infrastructure in space to support all that. And this is what that quote is about. At Axiom, we're like to take a leadership position in pushing all the elements required to start growing data infrastructure in space. So we're working with 2 particular companies shown here, one for the demonstration of high bandwidth communications between a space station and satellite assets to prove that you can push data in a heterogeneous way between assets in space. And also, last summer, we worked with a company in the UK to demonstrate the world's first quantum encrypted communications link between the ground, space, and back again. Cybersecurity is going to be a big thing in space, both for commercial space exploration and national security purposes. And going back to Sid's slide about the use cases and why doing things on the edge why is it important to do things on the edge? And you talk about low latency, you talk about on-prem processing, and you talk about residency. And all those things apply to space. Low latency. Right now, our networks are quite slow in space. So adding edge compute to those network nodes actually helps significantly reduce the latency of getting data back to the ground or back to where it's needed. On-prem data processing, again, the same thing. Let's think about a spacecraft traveling to Mars. It sees solar flare or radiation particles coming at it. You need that data processing on-prem to tell the crew to go hide in the shielded area because there's a solar storm coming or something like that. Right? So there's definitely applications in space where the 3 tiers of why you need edge compute make sense in terms of use cases. Which brings me to the future, and this is my last slide. Our CEO talks about hundreds of people living and working in a next-generation Axiom station. It's no longer a station, it's a city, orbiting city in space, and that's depicted by the artistic representation on the far right. And our visions for that by 2040, we believe it's realistic. And that's what we're doing, what we're doing today with sending private astronauts, building a small space station at first, module by module by module, because the culmination is to address all those economic opportunities I talked about a few slides ago and conduct them as part of a growing and sustainable human population in low Earth's orbit. We're also working with NASA on next-generation spacesuits, because part of that vision is growing human population in cislunar space and the moon, and eventually Mars. And thinking about how all this interplays with data, right, it comes back down to the economics and the economic opportunity. As human population grows in space, to address all those economic opportunities, commensurate growth of data needs and commensurate growth of the data infrastructure required to support those data needs of that growing population addressing economic opportunity. It's all a feedback. So that said, we're very excited about working in AWS. I think our visions are very synergistic. Thank you for your time. I'm going to introduce my friend Maciek, who's going to be talking about innovations of cloud applications for elevators. Maybe space elevators someday, not today, though.
Thank you, Jason. Yes, and I think we've been actually brainstorming about how to build an elevator to your city in space. So now let's move from the vision of city in space to how do we actually improve cities on Earth. So how do we get ready? Before I get started, I think a key message I think that you are hearing from Sid, from Jason, from myself is that edge computing is not just a vision. It's not just a future. It is actually here and now. And we're taking advantage of cloud and edge technologies, like in case of Kona, to truly deliver amazing experiences to city dwellers. So what I'd like to do in the next couple of minutes is to invite you on a little bit of a trip to explore co-innovating urban journeys. And you'll be joining my wife and I in Chicago. We are just getting ready for a couple of days of meetings, and unfortunately, my wife gets sick. So we order some medications from the pharmacy a couple of blocks away. We order some food items that she wanted. And yes, you guessed it. So we have a robot moving from the pharmacy a couple of blocks towards the hotel, delivering medications, and we have a drone flying with food items. And you can say, all right, is it real? We've been talking about drones and robot deliveries for a while now. You've heard the announcements from Amazon, from FedEx. They're kind of scaling down their robot and drone deliveries. But I can tell you it definitely is real. Last year, I spent a couple of months in China, and I got a lot of my deliveries, actually, through robots and drones. And our company's headquarters is in Espoo in Finland. And if you go to Espoo, you would see little robots roaming the streets and delivering food items from grocery stores to our homes, especially in the winter. It actually comes in handy. So yes, this stuff is real. But anyway, these both a drone and the robot deliver their payload to sort of a delivery area in the hotel. The payloads are being transferred to robots inside the hotel. These robots quickly go to the elevators that are already waiting for them, go to the 41st floor, deliver medicines and food items to my wife. And of course, these are great examples of edge in action when we actually using both edge processing, edge sensing, inference engines in these cases as well. So as my wife is being taken care of, I am ready. So I call the elevator and go down to the lobby. And of course, the elevator is working because we're running predictive preventive maintenance on it. In this case, we can anticipate roughly 70% of all the failures before they occur. And these numbers actually keep increasing every year. And in the elevator itself, in the car itself, we're running actually two visual sensors that can sense, for example, how many people are in the elevator. If somebody is bringing, let's say, e-scooter, which could be a kind of a fire hazard, if there's some unruly behavior, whatever the use cases the customer requires. And yet again, as Sid talked about some of the drivers for the edge, we're processing all of this data locally in full compliance with privacy and GDPR rules so that no personal information, no people's faces and so forth are being transferred. We just get the insights from the car. And then I exit the building, go to the building next door where Kona's office is, and I've been there a couple of times. So my app, my Kona employee app is actually interacting with the infrastructure, and I seamlessly go through the turnstiles and being guided to elevator C and go to 12th floor where my first meeting is happening. As I'm going through the process, I noticed there's a couple of other people approaching the elevator bank, and I realized that we're actually running a little bit of an experiment there. We're looking at sort of different people's behavior. One person is clearly in a rush. They're walking back and forth, and there are two people drinking coffee and chatting. So we can detect that, and we can potentially say, all right, this person that is in a rush, maybe we should give them sort of priority and get them to the elevator 10 or 20 seconds earlier, versus people who are chatting, maybe it's OK for them to wait. We're not sure whether this functionality is useful, but we're just testing it in the process. And I can spend another 2 hours giving you all kinds of use cases for cloud and edge applications across every industry. But I think you're starting to get the message, right? That when you think about KONE, we are a 123-year-old company. We traditionally have been developing elevators and escalators, doors, turnstiles, and these types of equipment. But over the last 2 decades, increasingly, we started focusing on delivering experiences to city dwellers. And KONE's mission is to improve the flow of urban life. I actually joined KONE 3.5 years ago, and primarily because this mission actually spoke to me. I was inspired by it, and I actually adopted the mission. Because when you think about it, there's roughly 1 billion people that use KONE equipment and services and solutions every single day. 1 billion people. And we thought, would it be nice if each of us city dwellers, could actually move around buildings, neighborhoods, and cities with smiles on their faces? And that's what we actually set up to do, this is what all these examples and use cases are all about. It's like, how do we truly enjoy our experiences in cities, maybe before we start venturing outside into the space. So we're testing that. But we also realized that in order for us to offer these types of scalable experiences across multiple cities, across millions of buildings, we needed a scalable architecture. And that's why we partner with AWS. Traditionally, we've been sort of a cloud-native company, and we've been one of the early adopters of cloud. And like probably many of you, we've been sort of infatuated with this idea of data as a new oil. We've been collecting all kinds of data, sending all the raw data to the cloud. But then over the last 5 to 7 years, we realized that data is not equal, that we should be smarter about it. And that's why we started to think about this sort of a cloud-edge continuum. When you think about, let's say, our 24/7 connected services, the predictive preventive maintenance service, do we really need to register all the sequence of events that are happening? Or maybe we just sort of do a sampling every 15 minutes or so. How many times the door on the 5th floor has opened? How many starts and stops the elevator had? What was the total length of the trip that elevator has taken? And then process the data locally and just send the insights to the cloud. The same for video and sensing and so forth, right? If we actually optimize the use of the edge, we can reduce the number of, the amount of data that we transfer or we store by 80 to 95%. And the good news is that as Sid has been walking through some of the services that are available, that we've been actually able to roll out a lot of these services fairly easily by leveraging the AWS services. So this preventive predictive maintenance service that I mentioned, we actually have close to 300,000 of elevators already using our predictive preventive maintenance service, and our customers actually paying for it. And the process is fairly straightforward, right? So we ingest the data into AWS IoT Core. Then we use a managed Kafka service to move the data real-time into KONE Analytics engine. We're leveraging services like Glue and EMR to process the data. And then we use the sort of universal APIs that Sid talked about to send the insights and outcomes to either our technicians or to our customers as well. Maybe one more example when we started, when the pandemic started, one of the key use cases that our customers have asked for is, hey, Connor, can you help us move or enable people to move from, let's say, a train station or parking lot to their office or to their apartment? And in order to enable this kind of a smooth trip in a timely and sort of a safe manner, we would typically interact and integrate with 9 different classes of partners. And from that perspective, as Sid mentioned, having a consistent set of APIs that we can integrate with partners, whether this is in the cloud or in different stages all the way to the edge, has been extremely useful for us because it gave us the ability to build flexible sort of engagement models with customers and provide these kind of services in a consistent way. So we talked about that at some point we may be actually building cities in the future. One of the things that we actually have been experimenting is using our mind to control the infrastructure. You can see on the picture here, I've been sort of testing this concept of putting this little helmet on and using my brain to call the elevator. And actually, the technology works pretty well. But it's probably fair to say that the commercial viability of these types of interactions is probably a couple of years away. But the good news is that using today's technologies that we've been discussing in this session, we can offer amazing experiences to city dwellers. So what I'd like to do is to invite you to join us in this quest. Let's work together to develop amazing services and solutions. You can do it easily if you are AWS customers already. We can integrate our solutions together. Let's work together to provide amazing experiences for city dwellers. And yes, let's work together to make sure that every person who lives in cities can move around buildings, neighborhoods, and cities with smiles on their faces. So please join us. Thank you. And Sid, let's talk about the next steps.
All right. Thank you, Maciek and Jason, very much for the excellent insights into how you're using AWS. And we have a couple of minutes left here. So you hopefully got a very broad and deep view on how AWS is extending the cloud to the edge, the different variety of use cases with a different portfolio of services. And we look forward to seeing you at our booth in the AWS Hybrid Village, AWS Hybrid Cloud in the AWS Village section. A couple of shout-outs. We have some good edge-centric sessions lined up. I'd like to draw your attention to the leadership session on Thursday at 11 a.m. That's Wayne Duso and Jan Hofmeier will give the keynote on the hybrid edge. And then we have some good sessions lined up for our services across Snow, Outposts, Local Zones, and IoT. All right. Again, thank you very much. I think that concludes our session. We'll be at the back, myself, Maciej, and Jason. So please feel free to come in the back and ask us some questions. Thank you.